Look at this image. It's a deep-field photograph captured by the James Webb Space Telescope. In this picture you can see a galaxy named Alkananda. Scientists say this galaxy has a well-defined disk with two perfectly shaped spiral arms wrapping around a dense central bulge. It spans about 30,000 light-years. What makes this even more shocking is that its structure looks almost exactly like our own Milky Way. Even though this galaxy formed extremely early in the universe, this discovery completely challenges our existing theories. According to the standard model of cosmology, galaxies like this, large, organized, and spiral-shaped, should not have existed so early. Yet, we have been finding many galaxies like this in the early universe. Right now, no one has a clear answer. And that's why cosmology feels like it's in the middle of a revolution. But wait, there's something even stranger and far more unsettling that the James Webb Space Telescope has uncovered. These new findings are genuinely worrying scientists because they look nothing like anything we've ever observed before. In another study, researchers also detected signs of something completely unknown that seems to have existed at the very beginning of time. Something that may have shaped the universe in ways we still cannot explain. According to scientists, the Webb telescope is uncovering something big, something that could change our entire understanding of the universe. In this video, I'm going to break it all down for you step by step. And trust me, it's going to blow your mind. But first, there are a few important things you need to understand. According to the laws of gravity, its strength weakens with distance. For example, the Sun's gravitational pull on Mercury is much stronger than on distant objects like Pluto or those in the outer edge of the solar system. This principle isn't limited to our solar system. It applies universally from stars and galaxies to massive black holes. But in the late 1900s, something unexpected happened. When scientists began observing galaxies more closely, especially in the 1970s with astronomer Vera Rubin's work, they noticed something strange. Normally, just like in our solar system, you would expect that stars closer to the center of a galaxy should orbit much faster than the stars farther away. But surprisingly, scientists noticed that this is not what actually happens. Stars far from the centers of galaxies were moving just as fast as those near the core. Scientists believe that if stars are truly moving faster at the edges of galaxies, you might expect them to fly away into space, much like water flying off a spinning wheel. This is because the pull of gravity is much weaker at the outer edges of a galaxy. But surprisingly, the stars don't fly off. This unexpected speed suggests that there must be extra gravity at play pulling on these stars to keep them in their fast orbits. But with more observations and evidence, scientists realized that something invisible must be working behind the scenes. They called this hidden force dark matter. Here, dark matter means an unknown force. No one knows exactly what dark matter is or what it's made of, but many observations suggest that it has played a huge role in the formation and growth of galaxies. Well, according to this idea of dark matter and gravity, scientists believe that just after the Big Bang, when the first hydrogen and helium gas clouds formed, dark matter played a crucial role. Dark matter created invisible gravitational wells that pulled these gas clouds together. As gravity gathered the gas into denser regions, the clouds began to compress. This compression increased the internal pressure and temperature, causing the gas to release energy in the form of photons. Releasing this energy allowed the gas clouds to cool down over time. And as they cooled, they began to collapse even further, eventually forming the first structures in the universe, dense gas clumps that later became stars and galaxies. This means that galaxies grew from tiny structures into larger ones, developing slowly inside these cold collapsing clouds of gas. So according to these theories of galaxy evolution, early galaxies should be small, messy, and irregular because they were just forming. They should also be cooler with fewer heavy elements because they grew inside cold hydrogen-helium gas clouds. They should form stars slowly, not explosively. But new James Webb findings revealing galaxies completely opposite of this. We have already seen massive and well-structured galaxies similar to our Milky Way existing far too early in the universe. But recently, the Webb telescope found a galaxy that breaks another prediction. Early galaxies should be cooler and contain very few heavy elements. One of the strangest recent discoveries is a galaxy named Y1, located more than 13 billion light-years away. It emits warm dust and intense infrared light, signals of rapid star formation. But here's the problem. The dust in Y1 is far hotter than what scientists expect for such an early time in the universe. This means Y1 was forming stars extremely fast and enriching itself with heavy elements much earlier than our theories allow. Most early galaxies had cool dust because their star formation was slow. But Y1 is completely different. When astronomers calculated its infrared brightness, they found that this galaxy forms stars at an incredible rate, about 180 solar masses per year. For comparison, the Milky Way forms 1 solar mass per year. With all these new discoveries, the James Webb Telescope has challenged and in some cases completely overturned our previous assumptions about how early galaxies formed and what they should have looked like. In other observations, scientists also found that early galaxies contain far more dust than expected. This raises a major question. How did so much dust form so quickly? Did something happen in the early universe that we still don't understand? Another surprising finding is that for years, scientists believed that during the cosmic dark ages, the hydrogen and helium gas was extremely cold. It was supposed to heat up only when the first stars and black holes formed whose radiation ended the dark ages in a process called reionization. But new observations suggest that the gas was already warmer than expected even before the first stars fully formed. This means the universe may not have had a cold start. Something unknown may have preheated the gas clouds. Our realization models might be wrong. This is a major shift because no current theory fully explains what could have heated the universe so early. In addition to this, recently scientists also found that the expansion of our universe appears to be slowing down. If this trend continues, it could one day reverse, leading to a catastrophic collapse, what some call the Big Crunch. Even before this finding, other observations had already raised eyebrows. Measurements suggested that the universe's expansion rate might not be uniform. It could be different in different regions. And even stranger, evidence hints that the universe might have had a spin in its earliest moments. True, this could mean something truly mind-bending. Our universe might actually be the inside of a gigantic black hole. For scientists, these discoveries are both fascinating and unsettling. They highlight how much we still don't understand about the cosmos. One possibility is that the universe had a definite beginning like the Big Bang. Another is that it has always existed, what some call an eternal universe. In this view, the cosmos has no true start or end, but instead passes through endless cycles of expansion and contraction or exists in an unchanging steady state on the grandest scales. There's also the tantalizing possibility that our universe is just one bubble in a vast cosmic ocean, a multiverse made of countless universes, each with its own laws of physics. If we really are living inside a spinning black hole, then the outside of our universe might be just as real as our own, and it could be connected to other universes we can't yet see. The James Webb Space Telescope has pushed our vision deeper into the cosmos than ever before. But with every answer it provides, it seems to uncover two new questions. Can we ever truly grasp the nature of reality? Or is the universe in all its vastness ultimately beyond the reach of human science? In the end, a small request. If you guys want to support our channel, then don't forget to gift our amazing Webb Telescope image-printed t-shirts to your loved ones to celebrate the amazing discoveries of the telescope. Also, this will encourage us to bring more amazing videos for you. That's all for today. Don't forget to share your thoughts about this video in the comments.